in today's discussion, we are going to look at paper 5, and it's going to be a speed run crash costing. So paper 5, I think, as you all know, will consist of 2 questions. And generally, most of the struggle is in question 1. So we'll focus on that first, where you have to deal with experimental design. So when it comes to experimental design, normally I'll tell students, try to read the questions, because the question will give you all the hints and clues about the things that you need to include in your experiment. So I think today we will choose a recent one just to discuss, as an example to discuss. But I would choose something that people will generally struggle with, which has a circuit drawing. Because oftentimes, when there's a circuit that we need to include, then that is where the confusion happens. So it's been a while since a circuit-based question 5 was asked. So I think I will probably choose something from the magnetic fields chapter, which is CIE's favorite. They like themselves a good magnetic field. And also it has an equation that students generally don't like, which is a bunch of log and lons and exponents. So if you struggle with exponents, the very basic thing that you need to know is how to linearize the equation. Okay, let's start. So when it comes to experimental design, normally you will encounter a scenario that you may or may not see before. Okay, what you got to do is you got to identify all the variables or the physical quantities. One of the quickest way to do so is to look at the equation. Okay, so normally I'll tell a student, as you read or you build a table. So the suggested table format in the notes that I've given you, okay, so you see, I say already, analyze the situation presented, pay attention to the equation, tabulate the variable and constant so that you don't miss out important points. Because sometimes if we don't know that we have to write about it, it's not that you don't know the thing, you just don't know you have to write about the thing. Okay, so normally I would suggest a table that looks like this. Okay, so what you have is some physical quantity you list down low. Okay, and then the measurements. So always think about, what do I use to measure the thing? Okay, and then also what are the extra details that you need to write? Normally here would be all the marks already, except the analysis mark. Okay, so let's look at this question. It says that you can very easily tell that we are going to have to measure X already. But we read the question first. Okay, so a flat circular coil P is carrying a current, produces a magnetic field. When the second coil Q is placed with the center of a distance X from coil P, an EMF is induced. Okay, so we could induce an EMF in coil Q. It is suggested that the V is related to X by this relationship. V is V naught E negative Kx, where V naught and K are constants. So I'm going to now circle all the things. So we definitely are going to measure the induced EMF, okay? Because you want to test the relationship between V and X. So that means one of it is the dependent, one of it is the independent. Which one is easier for us to control? What do you think? Do you think it's easier to control the distance between the coil or the EMF induced in the coil? Then you're thinking, of course, it's easier for me to control the distance. Yeah. So this means, if let's say you think about the physical quantity, so let's say I draw my table, okay? So the physical quantity here, the independent variable is X. So basically we change X. And then the dependent will be V. Measure V. Doesn't mean that you change, you don't have to measure, okay? If not, how do you know how much you change? So now once you already identify these two main characters, then it's time to think about how do you measure them? Okay, so how are you going to measure your distance x? So we're probably going to use something like a meter rule because this is a length-based variable, okay? And this meter rule cannot float, right? Maybe you think of like, nah, I put the meter rule behind here to measure lor. Yeah lah, but then the meter rule, it cannot float, cannot be floating. So in this case, what we will do is we will probably need to clamp the meter rule. And I'm thinking, right, because this is the center of the coil, I also need to account for the fact that, you know, the coil is thick, right? So I probably need to measure this thickness of the coil and then thick and minus or something lah. Okay. So then the extra detail, additional detail, or basically the etc. here would be to maybe measure the thickness, measure the coil thickness. Okay, and then divide by 2. So whatever this T is, to find X, I will have to add that T over 2. So what I could do is I could measure the distance from here to here, the edge to the edge of the coil. Maybe this is A, okay, whatever alphabet you want to give it lah. Okay, so then you will measure the thickness and then T over 2 here because you want to measure to the center. Okay, and then T over 2 here as well. So you have to write this down lah. So measure thickness and then probably using a vernier caliper. And then after that, talk about T over 2. Okay, so all this we will talk about, or we will write it out inside your experiment. Okay, later I'll show you the mark scheme. Okay, what about V? V here is your induced EMF. So to measure induced EMF, we would think about using a voltmeter. So that means I need a circuit drawing here. So I probably need to make a mental note. Okay, now I need to draw a circuit for this particular question. Are there any additional detail? For induced EMF, right? If you want induced EMF in Q, then we need current in P. But not just any current. The current in P must be alternating. Because you need the flux inside here to keep changing. First in this direction, then in this direction. So the flux keep flip-flopping, like certain MCO policies keep flip-flopping. So because that change to cause a change in flux. Okay, you don't need to talk about the theory, but you have to know that we will use alternating current in the coil. All right, so what else? So we have V, we have X, and then design a laboratory experiment to test the relationship between V and X. Done. So you want to test the relationship between these two things. Explain how your results can be used to determine a value of K. So we kind of need to find K. And to find K, right, if let's say I extend my table a bit, I also need to consider what should be my constant variable. So sometimes it is very obvious what your constant variable is. You can tell from the equation. Go and watch the discussion video for FatMarch 2.1. That one got a lot of constant you can harvest from the equation. Unfortunately, in this equation, there's no other constant already because they want you to find K, and V0 is not really something that you can keep constant. So things that you can keep constant, right, is the AC, the alternating current in coil P, the number of turns in the coil. So they expect you to at least have some basic understanding of the physics that is going on, so that you know that if let's say you want to measure the induced EMF in coil Q, whatever that's happening to coil P must be fixed. So flux will be NBA sine theta. So right now, this one will have to be kept this way. All right. And then I think that's about it. Of course, how do you make sure this one is constant? Then you must measure using an ammeter. All right, the alternating current. So sometimes, if let's say you are doing a question with a lot of variables, for example, I'm going to do this exercise again, but for winter 20. Okay, so this is an example of how you can list things down. And then, okay, hang on. One more thing that I missed out. Okay, so you can continue the table, but it's actually not really necessary. You want to find the physical quantity K. So a lot of times, right, the mistakes that students do is that right now you have this. So you think about this, we are changing X and then we measure V. So maybe in your table, so all this is happening in your brain. Okay, so we have different values of X, and then we have different values of V. If I plot a graph of X, V against X, you look at the equation. If I plot V against X, I am not going to get a straight line whatsoever. I'm probably gonna get something like when X increase, V decrease, something like this. Okay, so we need a straight line graph to find our K values. So in order to make this graph straight line, I'll copy the equation first. What we do is we will ln both sides. So ln V is equal to ln V naught E negative Kx. So when you ln both sides, this will be ln A plus ln B E negative Kx. And what will happen is now you can rearrange again. And this ln E is 1. So what you have is negative Kx times 1. Because we can bring down the exponent. So there are a few identities here that I use. I use ln A plus ln B is equal to ln AB. So this is A, this is B. Ln AB is ln A plus ln B. Second identity I use is ln A to the power of n is equal to n ln A. Okay, can bring down the exponents. So this negative Kx can shoot down here. All right, and finally, the last one that I use is ln E is 1. You can press your calculator. So from here, when I rearrange, I can have ln V is equal to negative Kx plus ln V naught. So this looks like the form of y is equal to mx plus c. So from here, you can see that you want to plot ln V on the y-axis and the distance between the coil x on the x-axis. And after that, your gradient is equal to negative k. But did they ask you to find gradient or they ask you to find k? They ask you to find k what? So k, because you see, if you look at the statement here, it says explain how your result is used to determine the value of k. So you must go one step more for your answer. You must find k in terms of gradient. So k is negative gradient. And of course, if you want to find V naught, your y-intercept is equal to ln V naught. So V naught is equal to e to the power of y-intercept. But it's not that they want you to find V naught, so you don't write this one also, never mind. So you must also include this inside your write-up. Okay, so here's a sample answer that I will allow you to look at. And once you draft this out, it's a matter of putting it together in the form of 15 marks. So sometimes students, it's like, Miss, 2 pages enough, man. I run out of place. So I managed to find a sample script of someone, and I'm not going to tell you who is actually able to write this all in 1 page. But for me, I actually take more pages. Okay, so let's check out someone else's. right up here. Okay. So here is some sample solutions for that question. Okay. So the first thing, right, when you draw something, depends on your thought process. Some people, they prefer to draw first because drawing helps them think and then it's easier for them to write. Some people prefer to write first then draw. Up to you. Okay. So in this case, right, if they give you a drawing, you're going to start from this one. Of course, you could say, why don't I draw in a 3D format? Because I don't want to. If I draw a 3D format, the diagram is just harder to draw. And here are some examples of diagrams that are quite okay. All right, this one is okay, 3D. This one is weird, okay? So the first issue, right, is that whatever that cannot stand, okay, must be clamped. You cannot have things floating around. So your coil have to clamp. Your coil has to clamp. So make sure you clamp the coils here to here. You clamp the coils here to here. The second thing that you should know is that the ruler have to be clamped. So you can see I clamp the ruler. I clamp the coil, I clamp the ruler. I'm happy now. But I also need to make sure the ruler is parallel to the ground, right? That's why there's a spirit level here. Okay. And I also need to make sure the coil is not tilted. So there's plumb line here. So if we go back to the list of, go back to these notes, you will see that I provided suggestion about setup here. Okay. So whenever you measure meter rule, you must clamp and then use plumb line or set square. And then you clearly draw out the distance. Okay. So it doesn't matter whether it's vertical or horizontal. Basically any kind of length. Okay. Or let's say you want to measure length of certain things. Okay. So if there is no movement, the point here is to clamp down everything and then use a spirit level or a plumb line to make sure everything is aligned properly. Like this one is 90 degree and this one is parallel to this one. So you check this plumb line. This is the plumb line. All right, this is the plumb line. You're making sure that they are aligned. Okay. So once you clip everything already, second thing I mentioned just now is that you must have a way to measure the induced EMF. So on your diagram, a general rule of thumb is you must draw the main instrument. For example, the main instrument for this experiment will be the coil. And then after that, you have to support things that you cannot put on the table. If you put a coil on the table, the coil cannot be vertical. So support if needed. And then after that, draw the measuring instrument for all the variables that you listed down in your notes. So if you look at this one, probably need to draw meter rule and clamp. Probably need to draw voltmeter because we need to know where to put these measuring instruments in the diagram. So here, the measuring instrument is a ruler, so make sure you draw it. And then second one is the voltmeter. So we want to find the, okay, so there's a small error here. Didn't label coil P and coil Q. So coil Q should be connected to a voltmeter because we want to measure the induced EMF in coil Q. And coil P is the one that is connected to an alternating current. So the power supply symbol for alternating current is the waveform symbol, like this, the form of a wave. Okay. So if you put alternating current inside here, then you will create a changing magnetic field, and then it will induce EMF here. We need an ammeter and we need a rheostat because remember this current is kept constant. So sometimes you may write halfway and then it's not a neat thing one. It's not like you have this, you dream about this and you can draw the whole thing. So for certain people, they will start writing and then they notice that, hey, I missed out this part and then they will have to add to it. So generally speaking, you could draw something that is very big like this. Generally, I would suggest students that draw a little bit smaller so you have space to add to the side, especially if you're not sure. So the first thing or the first format that I want to mention is that you will always start with defining the problem. So please use point form. Normally, students, when they don't use point form, also weird things can happen. So you define the problem, P2. So I prefer something like this. The independent variable is the distance x between the center of the coil, or you could say change x. Dependent variable is the induced EMF in coil Q, and we call this E. No, this one should be V. Okay, because the equation use V. Ma. Constant variable is the current in coil P, number of turns of coils, and the frequency of alternating current. So this one requires, again, a bit more understanding about induced EMF, because if the frequency is high, it means that the current changes more quickly. So there's a larger induced EMF. So basically, you got to keep the AC constant now. All right. So sometimes you are wondering, what if I don't mention frequency of AC? If you don't mention frequency of AC, you won't get this D3 mark. But this D3 is additional detail. So in paper 5, question 1, you can score more than 15 marks. So any kind of these D marks you don't write, there's still a chance for you to get 15 out of 15, provided you write all the other P marks. So you state the problem, something like this. Then the next one, we go to method. You can write a header if you want. Okay, so your student didn't bother to write a header also. So here you can see it says use a large number of turns or high frequency current for larger induced EMF. Yeah, definitely. Because this induced EMF is very small, and then generally these coils will become very hot. Hang on, hot coil can write as safety, can. Okay, so don't touch coils or use heat glove as the coils may be hot. So you see, I can see the thought process of this human being. Okay, so now we already decide what current to set up here. Okay, then we need to figure out how to, measure X. So use a vernier caliper to find the width of the coil, then divide by 2 to find the center of the coil, and then measure X. Okay, so something like that. Measure X at different places along the coil to find average. So whenever you measure a circular shape, right? If you, again, go back to the notes I've given to you, any kind of like diameter or thickness, you use a vernier caliper or micrometer, repeat at different position and average, and you can never measure the radius. So if they want you to measure a radius, for example, a cylinder, you can't measure the radius of a cylinder. What you can measure is the diameter, and then you divide by 2, okay? You can't measure the radius of anything with a vernier caliper. All right, anyway, after, please mention and find average, because if you don't write and find average, then game over. Okay, use a variable resistor to ensure that the current is constant. So oftentimes, right, when you think about your constant variable here, you also should mention how to keep constant. So for current, it's very straightforward. We just use a variable resistor or a rheostat. Okay, so make sure the coils are at the same height above the bench with a ruler. Use a plumb line to measure to ensure both coils are vertical. Okay, so I prefer if this candidate says and measure X using a ruler, but he or she did draw a ruler here, see, and labeled. So I can give that mark. So this is like an insurance lah. But you want to double insure yourself, can draw the ruler in the position and then say using a meter rule. Okay, so make sure the coils are in the same height above the bench or the table with a ruler. Then use a plumb line to ensure the coils are vertical. All right. So linearize the equation to this one. So whether you want to show all this working or not, it's up to you. Not everybody need that many steps one. If you are good in maths, or if you're taking A2 maths, you definitely can hop your way to this format very soon. So for A levels, for paper 5 physics, this final line has 1 mark. This final line here, ln V is equal to negative kx plus ln V naught has 1 mark. So this student, lazy to write, or maybe the student write in the question page. So just transfer that equation over. So this one, okay. And then if the relationship is valid, so this equation is slightly different because it's not the identical question. If the relationship is valid, the graph will be a straight line with a y-intercept and negative gradient. So you need to mention the y-intercept. Okay. If a graph of ln V against x is plotted, k is equal to negative gradient. Okay, and then this question actually asked them to find the y-intercept. Okay, so this is a slightly different question, but very similar as well. So you can see this one, when you look at the mark scheme, right? Every line is 1 mark. So you define the problem. I prefer to use the term dependent and independent, or you can say vary x, change x, measure E. Okay, keep the peak current in the coil constant. So these two is 1 mark each. So if you look at the labeled diagram, it should involve coil P and coil 2, and it has to be supported. Normally, this support is in the form of a retort stand. Okay, so support that generally is not accepted is, you know, this one where they tie a string and hang there, and then you sneeze, and then this thing is just going to, what is going on? Okay, yeah, this one is an okay support, but I don't know why they have to draw the circuit out this way, but sure. Okay, this is okay. This is okay. It's very similar to the previous one. And they even draw the eye level, which is great. And they indicated how to measure the distance X and this distance L. Okay, so all this is pretty okay drawing. You don't have to draw very nicely. You just have to make sure all the things that need to be there are there. So this student use set square all over the place. Okay, sure. Okay, let's go back to the mark scheme. Okay, what else do we need? We need to mark X, and we need to label coil P and Q. Because without P and Q and X, there's no experiment. Okay, so you have two circuit diagram. One is the AC power supply or the signal generator connected to coil P, and then with the ammeter. And then voltmeter and or a CRO connected to coil Q. So if you just put the AC supply without a rheostat, it's still okay. You will still get this mark. Because all the rheostat that one all is additional marks later. So a method to determine X, okay, use a ruler or ruler shown on diagram adjacent to the coil. So you should draw where you would want to place the ruler. Imagine you are writing instruction for a friend who has never done any lab before. Find your favorite friend who is not a science student. You go like, bro, I need your help. Read my instruction and see whether you understand what is going on and what to measure. If the person don't understand, means you can refine your working. That's how people test recipe books. They write a recipe and then they pass to their friend who actually don't really cook and see whether their friend can follow the recipe or not. Think about it that way. You're giving instructions to someone who has never done any of this before. Okay, so M4, your method. So basically, first you say measure X using a meter rule, and you draw the meter rule, you get 1 mark already. But the one about the width of the coil is the sentence. So the sentence could be measure the width of each coil and divide by 2 and add to the separation of the coil. So what we'll do is we will measure from here to here. But for me, right, I would write A plus T over 2 plus T over 2 because or W1 over 2 plus W2 over 2 because right equation is pretty straightforward. Okay, so method of analysis, you plot a graph of ln V against X, and K is negative gradient for the correct graph. So these are all the extra details that we can add. Okay, so for example, do not touch the hot coil, use glove to position the hot coil, use a large current, use high frequency, keep the number of turns constants or the frequency constant. Okay, how to check the current is constant, adjust a variable resistor and keep ammeter reading constant. Measure, so whenever you want to repeat measurement for circular object, mention that you measure X at different parts, the word different has to be there, and average. Then position ruler horizontally, so use a spirit level, or measure same height from the bench on both ends. So you measure H1 here, you measure H2 here, then you make sure they're the same lah. Provided your bench or your tabletop is okay. All right. And then you also must have a way to keep the coils parallel. Until maximum, use a set square to ensure the coils are right angle. Plumb line would work too. Okay. The equation. And the relationship is valid if it's a straight line produced. Okay. So this is generally how it would look like. Okay. This equation doesn't look like this equation, because it's a slightly different question, okay, but the format, almost every one of it is the same. Well, that means they repeat almost entirely. Yes, for this one, yes, but they don't always repeat lah. So don't hope for that. Or rather, you also don't know which one they will repeat, right? So just study everything more. So if you look at all of this, we have so many different experiments that you need to think about. Okay, so normally, what I would suggest is that you go through the past years and then just think about how you would write it. And then if let's say you don't know how to draw the diagram, then discuss with your teacher or come and talk to me. Okay, so when it comes to the format, right, if you want to follow this format, it kind of settles off most of the things, because here I got talk about things like, normally it will be, okay, so for diagram, it can be 2 to 3 marks in the diagram. Depending on the mark scheme, every year is different. So if you got diagram to copy, you copy. Sometimes they don't give diagram, which is a sadness, okay? And then all items needed to measure the variables are clearly labeled and positioned at the right place. Draw a circuit diagram if you are doing a circuit experiment. Like for example, the first example we did today was a circuit one. Clamp and secure all objects that need support. Unless you're talking about like placing most things need a bit of support one. So if it cannot float, it cannot stay there without your hand holding it, that means your retort stand is your hand. Okay, so after that, use the table, then you write in point form. No, how will you vary the independent variable? How will you measure the dependent and independent variables? What things do you use? Meter rule, voltmeter. Okay, repeat measurement. If the shape is circular or irregular, say different position and average. Okay, you could also say repeat the experiment for the same value of X to obtain more value of induced EMF and average. Be specific, because normally vague answers won't get marked one. Okay, so the analysis is straight line only. Don't use log or ln graph unless the equation is with exponents. Always use y equal to mx plus c to decide what kind of expression you want to use. Okay, and then express the constant as the subject of your equation. So instead of gradient is negative k, we must write k is negative gradient. Instead of y-intercept is ln v naught, we will write v naught is y-intercept, e to the power of y-intercept. Okay. Okay, discuss the relationship validity from the graph. So from here, what I will write is the relationship is valid if the ln v against x graph is a straight line with negative gradient because of the negative k and y-intercept. Don't just say straight line, because this straight line doesn't pass origin. We're going to expect to get a graph like this. Ln v against x. Okay. So this is the ln ones. So once you have done that, okay, you follow this, then any extra detail, such as safety or precaution, always think about your skin and your eyes. Wear gloves, wear goggles. If you don't know what to write, just spam everything. Okay. Normally, there could be high voltage electric shock, or they could be hot objects. Okay. So normally, when you set up the experiment, use plumb line, set square. So basically, it could be by the time you write this part, or you might be thinking, oh no, I've forgotten to say that we use a spirit level to ensure the ruler is horizontal. Just add. You can just add at the back. Anything else you can add here. So they are not very strict about the actual setting. Does that make sense? Because sometimes you write already and then you go like, hey, I've forgotten to mention that the current have to be constant. Then you write here, no, current in coil P is kept constant. Okay. Or you could even start writing here, constant variable is current in coil P. So different person will write differently. As long as it's within the question, you are okay. All right. So I want to look at a slightly different experiment. Okay, just as a pivot point. You see, wow, so many variables. Okay, let's crop this one so I can draw on it. Then we can think about how would you write out this table for that particular experiment. So what you can do during these few days is just go check out a bunch of experiments, the different type one, the weird ones, the things that you never see before. It's like you go shopping, like, window shopping, but for question one. Okay, so for this, again, I'm not going to write the whole experiment from scratch. If you want to see me write the whole experiment from scratch, go and watch the Feb March 21 paper that I did with my friend and colleague, Miss Ellie. It's available on YouTube. Okay, so here we have a trolley. So they give you something that you start reading. Motion of a trolley on a wooden surface. What's the M here? Sure. A mass M is placed on the trolley. By the way, this question is ON20 paper 52. Okay, so you put a mass M here. By a string, mass P is attached to a trolley by a string which passes over a pulley. Oh, we have a pulley. Okay, hang on. We need to include pulley in drawing. And then we need to also have mass P in drawing. So when I read the question during exam, I will immediately begin to circle all these things. This is mass M. This is mass M. Okay, boss. Trolley is initially at rest. Okay, so I got to make sure that there is no force on release, meaning I don't push the trolley lah. Student investigate how the speed V. Oh no. So speed V means this one I need to measure. Figure out how to measure V. Speed V of a trolley at the distance D. Okay, so this one also need to measure. You see, we are harvesting all these things. And talk about how to measure this. How the speed V of the trolley at the distance D from the initial position varies with M. Okay. I see. So the variables, the dependent, independent variable is V and M. So purpose number one, design a laboratory experiment to test the relationship between M and V. Okay, now it's time to stare the equation. Okay. Explain how your results, purpose number two, can be used to determine the values of Q and R. Then the rest is just standard stuff. You may draw a diagram, blah, 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 write your instrument. Okay, come. I draw a table now. So the first thing that I'm going to draw is so this is the physical quantity. So the first one that we have is V and M. Again, it should be quite obvious which one is easy to change and which one you measure. I can change the mass M that I put on the trolley. 10 gram, 20 gram, 30 gram, 100 gram, 2 kg, it doesn't matter. What I cannot change is how fast the trolley is moving. Okay, so I'll probably, so you might be thinking, if let's say you're worried about the pulley because you cannot visualize the experiment, so what you can do is you can sketch here. I'll probably include a pulley here. So there's a pulley. And this pulley probably cannot stay there, need to clamp the pulley. Okay, and then there's a mass P. There's a string here attached, and the mass P is here. Whee. Oh. So what we are changing is the speed of the trolley after it travels through a distance D. So this trolley is probably going to go, maybe I measure from the front. So maybe the trolley go from here to here. So this is D. So maybe after this, your trolley is, I don't know. D is obviously going to be constant. Okay. So it will have a certain speed. But now this one actually got a lot to write, guys. This one is way more to write than the coil thing. So we have PQ, right? The physical quantity. So there's the independent, the one that we change, dependent. Then we have the dependent, the one that we measure because you change the mass, you change the velocity. So this is mass of the trolley, mass on the trolley. Then this dependent is velocity of the trolley, V. Okay. Constant variable. Okay, everything else is constant, miss. Yes, Q and R, you don't write law because you put QR here also no point. You don't know what QR is. If you don't know what Q and R is, how are you going to keep them constant? What else is inside your equation? We have done V, we have done M. We can't do Q and R because we actually have to find them. Unless you are God, you can't change the acceleration of gravity. So what else do we have? We have to keep D constant, the distance traveled by the trolley. Distance traveled by trolley, D. And then this P leh. What is P again? Oh, mass P. This mass that we hang on the pulley. But of course, we need to keep the mass P constant. Because you put different mass, the trolley will accelerate differently. So we all know this. Okay, so I think we are satisfied. Everything in the equation is more or less accounted for. If there are other things that we think should keep constant, we can write later. Okay, so how to measure? So we all know how to measure mass. We use a top pen balance, the one with the digital scale one. So this one, no problem. Velocity, how to measure velocity? A velocity meter, no such thing. What is a velocity meter? So if you want to measure the velocity of something, what you could do, and you don't know, here's a handy dandy list to refer to. Average velocity or acceleration. You probably need to measure time and displacement of the object and use a relevant equation of motion. Okay, so this trolley is accelerating. Miss, how you know the trolley is accelerating? Dude, the trolley is initially at rest. So the trolley is initially at rest. It means that the trolley has to be accelerating. Otherwise, it won't move and you won't have an experiment. Okay, so if I think about this, or rather, let me draw out the trolley for you. Trolley is here. And after a certain time t, the trolley is here. So I can measure this distance d using a meter rule. And then I can obviously time the trolley t. So obviously, velocity is not distance over time. Why? Because acceleration is not zero. At least I hope your kinematics are okay. So then how do we find velocity? We will have to use v squared. Wait, we don't have the acceleration. So we use the equation with no a. S is equal to half u plus v times t, right? But this is d, the distance traveled. U is 0. We are looking for v, and the time t can be measured. So then from here, v will be equal to 2d over t. So all this back of the napkin calculation, you have to include the equation. So we'll measure d. D is also here, needed, but d is measured using meter rule. And t is measured using a stopwatch. You want to be fancy people, you can use a light gate. You can even video and review frame by frame. Okay, the more important thing is you calculate v as 2d over t. So these are just how to measure and all the extra details. Again, you can always refer to this one because if you look here, if I talk about anything that is traveling, movement involved while measuring, you can view video playback frame by frame. You can repeat the measurement and average, but the repeat one we can write later. All right, so velocity is done. This is done. I think distance d is pretty straightforward. We measure using a meter rule, and mass p kept constant. Just use back the same mass time and time again. Okay, so I think we can write the experiment already. So when writing out this one, again, we start off with the statement, the problem statement. So let me put it down first. Oh no, wait, we also need to modify the equation to get a straight line. Okay, let me steal the equation again from the question paper. Where is the equation? Okay, I'm gonna linearize this equation. Okay, how to linearize? First things first, identify your variables that you measure and you keep constant. So your independent and dependent variables are highlighted. So basically, if you do the experiment, you don't have to draw the table when you write out your experiment, but for some students, it helps their brain. So maybe you have mass in gram, you change different mass, and then you measure the time, and then after that, you can find the velocity. Of course, we can't plot m against v because it doesn't look like a straight line. So what to do? Don't know what to do. Cross multiply. We want to linearize the thing. So here it will be 2d pg minus q is equal to v square m plus r. So I need v to be on one side and m to be on another side. Normally, when we do an experiment, the top part here, let me zoom in a bit. Normally, when we do an experiment, the top part here would be the dependent variable. So something v v square or 1 over v square. And then whatever that is here is normally the independent variable. So it's easier to measure. So to help your brain, I'm going to move the v square one side. Can I exchange place? Yeah. So basically right now I have 1 over v square is equal to this one can be m plus r, okay, over 2d pg minus q. Basically, I bring the 2d over. I have to isolate the m. I have to isolate the m. So 1 over v square is equal to m over 2d pg minus q plus r over 2d pg minus q. If your m is not sufficiently isolated for your brain, I will write another line for you. This will be m, big bracket, 1 over 2d pg minus q. Then this is the whole thing. But what is important is now you can take y is equal to mx plus c, or rather x times gradient plus y-intercept. Okay, so this is your gradient. This whole 1 over this whole thing lah. This whole thing is your gradient. Okay, and this whole thing is your y-intercept. Means they want us to find q and r. Yes. So from here, we need to modify a bit. And to make my life easy, I'm just going to let the gradient be equal to g. So from here, I can say that g is equal to 1 over 2d pg minus q. When I rearrange to find q, this is such a, see, exponents are nicer. Anyway, we're gonna soldier on. So what we have is 2d times g. And then we will have pg. I'm going to open up the bracket, okay? So minus 2d times g. If I bring out and multiply, 2dg times q. This is equal to 1. You throw this on one side, 2dg pg. Capital G is gradient, is equal to 1 minus or 1 plus 2. Wait, I should flip it the other way. My bad. This one will be minus 1. I exchange place. What I'm trying to do is I'm trying to isolate out this Q. Can I change color now? OneNote, are you okay? Am I allowed to change color? Give me a sec. To close and open again. OneNote cannot deal with linearizing equation. Where were we? We were looking for Q. Q. It's just algebra, guys. Don't worry about it. So these two dg, pg is here, minus 1. And then the other side, you will have 2 dg q. Okay, now you can write q already. Your 2 dg, don't go and cancel. Cannot cancel. If can cancel, I also cancel already. Pg minus 1 over something like this. Don't bracket, also never mind. Okay. So if you want to substitute gradient as something, you can, or you can keep writing this one as gradient, 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 gradient. We're going to repeat the same thing again for y-intercept. Because once we find q, it's such a pain, we can now find the y-intercept. I'm going to let the y-intercept be equal to c, okay? So c will be equal to r over 2d pg minus q. The good thing here is we already have q. So we just need to find r. So r is equal to c, y-intercept, times 2d pg minus q. Okay, the end. Q is found from this equation, where g is the gradient. Yeah, so don't be fooled by thinking that, oh, I'm more familiar with this equation. Dude, when you want to linearize this one, whenever there's a fraction, it's always a slight headache. And let's check out the mark scheme, because this is obviously not the only straight line graph you can draw. There are many, many types of questions. Okay. And there are also many types of suggestion. So by the way, these two expression will work. So I have already found Q and R, which is the purpose of the question. So what graph do we plot? I'm going to plot a graph of 1 over v squared against m. And then you can say the relationship is valid if the graph is a straight line with y-intercept that doesn't pass through the origin. So normally this is A1 mark. Then you find your Q and R correctly. Actually, this one can simplify a bit if you want to. Q will be the 2dg will cancel, so it's PG minus 1 over 2d times gradient. This part or this one, this is A1, one of the analysis mark. You find R, this is the analysis mark. Okay, like that lah. So how would the mark scheme look like? We now have to bring all of this together. So all of this is like, before you fry rice, you chop up all your ingredients and people don't see your prep. This is all the prep. Of course, how quickly you do this depends on whether you can. It looks a bit slow because I have to narrate every step. But hopefully, with basic algebra, you are okay. If not, then it's a course of 1, 2, 3, 4 marks. This is D mark. Okay, let's look at the answers. So first step, we are going to define the problem, right? So think about your P. So normally I would say problem statement or defining the problem or something like that, because I like to follow the mark scheme. Because I know the examiner is looking at the mark scheme. And if they look at the mark scheme and I make their life easy, they will make my marks easy. Or at least that's what I think. Okay, so the sentence makes sense. So The first one, when you define the problem, you say M is the independent variable and V is the dependent variable. Done. All right. Keep P constant. Did I say keep P constant? Yes, keep P constant. Yay. So I got 2 marks. You know what? To prevent myself from needing to scroll up, scroll down, and giving everyone, including me, some motion sickness, I'm just going to crop this whole thing. Plant it up here. So we could refer to it. Okay, I'm going to briefly cover the equations there, but I think you get my point. Okay, so now we need to think about diagram. How do you think your diagram will look like? We need to have a pulley, right? And then we need to have the whole set up. So here is how my diagram would look like. I would draw the surface of a table. Hopefully you draw with ruler lah. Okay. So this is the wooden surface. Okay. I'm going to draw the pulley. So I would label this one is the pulley. Actually, I should draw with pencil, right? So I can change color and then it will look easier, but I prefer to pretend I'm doing this in the exam now where I only have pencil. Okay. And then they put a wooden surface, right? So I'm just going to draw another extra wooden surface on the bench. Just give me a sec. So, and then to differentiate things, I will make sure I label. So this one is the bench. This is the wooden surface. Okay, what else do we need? We need a trolley. Great. So I'm the kind of student that will forget to label things one. So I will draw and I label at the same time. Trolley. Then we have the mass M on top of the trolley, right? So here is mass M. Then we need a string. String to the pulley. String here. I'm going to tie this one here. This is mass P. Okay. We also need to talk about distance D. So I don't know, maybe here. So here to here is D. Any kind of distances or length that you measure should be able to indicate on the diagram lah. Okay. So you see immediately, right? You imagine you do this experiment. What are the limitations that you encounter? You'll be like hard to determine when the trolley passes through this. So what you would normally do is you would do some marking, right? So what I'll do is I'll mark here. So I'll just label here. Marker on the wooden surface. Okay, I think I'm good. Okay. An extra thing about measuring time, this timer, means if I want to measure light, if I want to draw the light gate, how do I draw the light gate, right? So you don't laugh, but I show you how they draw their light gate. By they, I mean CIE lah. How does Cambridge draw their light gate? Here is the paper of Feb March 21, paper 52. Okay, I have recorded a discussion about this. Go watch lah. Okay, so here, this is how they draw light gate, guys. Look at their light gate. Just look. This is their light gate. So in physics, it is not. It doesn't matter whether it's pretty or not. The important thing is that you have to draw the light gate. But of course, then you can say, Miss, if I draw the light gate here, the light gate is floating. I need to clamp the light gate. Correct, lor? So if this is you, what I'll do is I would draw 2 light gates here. Okay, I'm going to zoom in a bit. Okay. And then I will clamp the light gates. Something like this. Please make sure and then I have to move the label for D lah. Please make sure your retort stand looks like a retort stand lah, okay? So these are my clamps for my retort stand. This is D. As you can see, I kind of am really not good at drawing, but it's enough. So here are the hacks that I learned as a student. Retort stand can always draw last. Maybe in real life, you will need a rod, but the retort stand can always draw last, or you can draw a bigger diagram. Okay, so this is my retort stand. Label. Retort stand. Okay, I think I'm more or less satisfied. If you want to, you can draw a ruler here, but I will just casually mention that the ruler is, you draw marker already, ma. I can measure a distance between the marker, so I don't need to clamp the ruler. Oh, light gate. Didn't label light gate. Light gates. So if you have a habit of doodling, you can do this for a few experiments, so you get a hang of it. Please use ruler, okay? I don't have ruler, so I now draw things like a potato, but you should be able to use ruler and draw something a bit nicer. By the way, if you do this exercise for a few questions, you can more or less know, and then you check the mark scheme, like what I'm doing. Okay, I'm satisfied with my diagram. Let's see whether I'll get marks. The next part is the method mark. So this method mark, right, by the way, basically the whole idea is one line, one mark. Okay, so let's see. Label diagram of workable experiment, including P attached to a string. So you must have all of this. Okay, I got P attached to a string. String passes over a pulley. Yes, supported pulley. I use a G clamp because I want to clamp it to the surface of the table. Okay. String horizontally attached to trolley. Yes, correct. Trolley is labeled. P is labeled. I even labeled mass M. Okay, I got 1 mark. Next. Determine V. So you see, light gate attached to timer to measure V. So the light gate, right, is actually, okay, if you don't know how a light gate looks like, all these boxes physicists draw, but they never show you IRL, which is a bit sad. Hang on. So a light gate looks like this. Okay, so you see this connecting device. We can put this inside a computer, and the computer can calculate velocity for you. So what we do is when we want to find the velocity of something, let's say this is your trolley, we will stick a card on the trolley. And then we allow the trolley to pass through the light gate. The trolley will start timing here, will stop timing here. If you start timing here and you stop timing here, they will find the average velocity. The device itself, the computer itself will be able to find that velocity. Okay, so generally that's how it works. We connect this to a computer or a CRO, which they are not showing me right now. Something like this. There's a device one now. You can press through different modes. Okay, so these are all light gates. So you want to use light gate, can. Motion sensor connected to data logger, can. Ticker timer tape also can, but this one all are not very common that you use in the lab. I write about something that you used before. Measure D and T with timer or a stopwatch or a light gate to timer. So my light gate is to measure time. Okay, if you want to use the light gate to measure speed, your setup will look something like this one. You want to use light gate to measure speed, you must include a card on top. So if you try out this experiment from Feb March 21, see, miss the equation. Okay, yeah, just go do. You see, they find velocity using length divided by time. And the length of the card is coincidentally also 5 cm. It's not a conspiracy. Also standard light gate, 5 cm. You stick it on the trolley. But my problem with the light gate is that you need to stick the card and then you need to put the mass. And I want the mass to be as center as possible. So the card have to be to the back. And I don't know whether I can align the light gate. So I don't know. But it's fine. I don't think they care about that level of detail. So put the card here, okay, and then let it go through the light gate. So this is an example of, so I'm going to just put this here, how you would change the drawing a bit. If let's say you want to use the light gate to measure, so what we'll do is, this is your trolley. Instead of your glider, you put a trolley here. So this is light gate to measure V. This is light gate to measure T. Okay. All right. Let's carry on. Either way lah, all okay. Use a balance, a top pen balance to measure M. Ne? Measure M, measure DT. Wow, all this mark also get, okay. And then finally measure D with a ruler. Of course, there, D with a meter rule. Statement can already, just a statement. D is measured using a ruler. Okay, you are done. For method, 4 marks. 4 marks. Not that hard. If you know that you have to write these things. And that is how I generally suggest people do. Just harvest the equations and then put stuff there. All right. Here are additional details. Generally, my advice with additional detail is you gotta think about, again, you are doing the experiment. What is going on? So first thing about safety. What kind of accident could happen? Maybe mass P will fall on your leg. Okay, lor. To prevent trolley from falling, use a cushion, a sandbox, barrier for the trolley. Now, if you see people do explosion experiment, they will put an entire barrier to enclose here, or you could just draw a sand pit here. Sand pit. So this is what I mean by, I want to talk about a cushion. Okay, I draw here. Okay, keep D constant. Yes. Use large distances for D so that the trolley have enough distance to accelerate. Okay, method to keep D constant. Marking starting and end position. I just did that. Okay. V is equal to distance over time. For appropriate small distance on thicker tape, distance between light gate. Okay. Or you can use 2D over T if T is the total time measured. Okay. So when they say total time measured means you let go of P, you start your stopwatch. So it depends on the sentence. Okay. So for me, if I'm going to use 2D over T, I would say I actually would just not use one of the light gates, but can. So I will just add a label here. Starting position. So what you could do is, your first option is when you let go of mass T, you start the timer. By the time it reaches the end position, you stop the timer. Or you could allow the trolley to travel a certain distance, then only you start timing. So they are both okay. Hope that makes sense. Okay. So if it's distance between the light gate, and then after trolley begins moving, then can. But this is just average velocity. Okay. Method to ensure the wooden surface is horizontal, use a spirit level. Why, yes, because the surface have to be horizontal. This wooden surface. Did they mention here? I think they did. Or from here, it's pretty obvious that it's horizontal. If you don't mention this, it's okay. You don't need all 10 marks. Maximum marks you can score is 6 only. Okay. For the same mass, repeat experiment to find average of V. So this one, every question can write one, but your sentence must look like this. For the same independent variable, repeat the experiment to find the average dependent variable. So you must change it depending on the experiment. Okay, this one is the equation. I got this equation, remember? I crop that later, we go and compare. Okay, so if you show this, you get 1 mark law. Relationship is valid if it's a straight line, not passing through the origin, okay, or with a y-intercept. Method of attaching mass M to the trolley. For example, use tape or adhesive putty. Yes, stick the mass on it. So out of these 10 marks, you only need 6 to score full mark. But if you don't get any of these 4 marks, it will be a -1 because your experiment totally cannot work. Okay? Or if you don't list down your variable, you can't even start your experiment now. It's like, why are we here? I don't know. What are we measuring? I don't know. Okay, the last 4 marks are in the calculation. So I'm going to paste the equation here and confirm. Do I have the equation? Oh, there, here, see. Okay, so the equation here is your D1 mark. So there's 5 marks in the calculation. Okay, and then later on, if you talk about method of analysis, this is our method of analysis. It says plot a graph of 1 over V against M, or M against 1 over V. Can I choose the first one lah. All right. So Q is PG minus 2D times gradient. On there, here, this one. I already let gradient be G ma. There, yeah, I let gradient be G. Okay. And then, oops, let me move this one here a bit. And then your R is y-intercept. Where's my R? 2D times PG minus Q times y-intercept. There. Here. R is y-intercept times 2D. Okay, done. So this is what I mean by just because the equation looks simple, it doesn't mean it's simple. Just because the equation got exponent doesn't mean it's hard. What kind of equation you will get and what kind of setup you will get, because unfortunately they don't let you choose experiment. So you have to know everything. I'm sorry. And I don't think there's a proper way to guess this because the variables are just way too many. We are not asking you to set up the experiment. We're asking you to write a recipe for the experiment. All right. So that's what I think about question 1. Are we okay, people at home? I swiftly move on to question 2. I think generally, right, for this question, the way to do it is just practice like the way I did with the 2 questions just now. Just go through this process, sketch this one out, write it down, and then after that, you go and double check the mark scheme. It's the point that I think about all there, and did I miss out anything? After a few times of that practice, you should be okay. And if you want to, you can draw a diagram just to amuse yourself. All right. So that is question 1. In a nutshell. This one is from ON20, paper 52. Don't worry about the kind of equation that you will get because you don't know. So just list down the physical quantities. Think about how you're going to measure them. If there's any physical quantity you don't know how to measure, there's a list here. I also want to highlight the fact that there is one that they kind of like to ask a lot, which is using the Hall probe. So please know the difference between Hall probe and induced EMF. Induced EMF is due to the change in magnetic field. Hall probe is measure magnetic field. So one is measuring change and one is measuring existence. So there are 2 different things. So go and check out the Hall probe experiments. Yeah, I'm going to use the remaining time, if you have no questions, to move on to question 2. So I'm going to keep this one here. This is Q1. It's not a new one. As usual, all of this will be at where you normally find your notes now, okay? Don't worry too much about copying. Just focus on asking questions and making sure you understand. All right, so P2 now. So for paper 2, this one is data analysis. And normally, you also don't know what kind of equation they give you. They can give you anything. But I think the key skill that you need to have is, again, linearizing the equation and also to find y-intercept, gradient, certain constants, and also certain technique about drawing graphs. All right, so before I go on, I just want to point out that there are a few things that you probably, if you don't read, you probably don't know how to do. Hall probe is one, okay? Alternating current, you can read on the CRO, so that one is no problem. Wavelength of light, you use the Young double slit or diffraction grating, or you use filter LED. If you decide to use the Young double slit or diffraction grating to find the wavelength of your light, check out these experiments. Then you must include the relevant equation. I think volume, all this is okay. Angle, all that, no problem. Force, you use a Newton meter. Pressure, you use a manometer. This one, when this one came out, everyone lost their mind because no one expected pressure in winter 18. Go check out the question. But the rest, this one all is the standard stuff. The special ones are pressure, when read that one, force, and sometimes you have different types of force one. So go and check the May June 18 paper 51. Sometimes we use a top pen balance to measure the force. For example, the force on the magnet and the wire, your current balance. Okay. Other things that are a bit irregular, like I mentioned, is wavelength of light and using the Hall probe. You don't see coil, then immediately use Hall probe, okay? You better decide that the Hall probe is used to measure how strong the field is. For example, this one, we don't use Hall probe because we want to measure the induced EMF. This one, we measure the force between 2-point charges. This is the May June 18 paper. Go and look at it, okay? So you can go through this, all right? And then this one, you see, B is magnetic flux density at point P. This is where we use a Hall probe. They even tell you, uses a Hall probe. Okay, lor? So you just gotta go and, this is generally, right, if you look at my compilation of set A and set B, it should be enough for you to do most of the questions. Because I compile a variety. There's kinematics here, and then there's some weird Young modulus. Then got wavelength of light. What this? Okay, I will give you the year later. Then this one got LDR one. Why? Why no equation? Why no diagram? I got standing wave. Okay, no? So go and go through the question. Set A is the easier one. Set B is the one where I bring in all the magnets and the circuits and the alternating current. What is this? Don't even have a drawing. Okay. Go and read up everything. But for paper 2, if you don't know, it's fine. Just use y equal to mx plus c to hack the equation. Here are some common uncertainties. Okay, so generally, right, the first skill that you need to have is how to linearize. And if you don't know, there is also another more broken down version video in the playlist. We'll talk about different types of equation. So generally, you may get a polynomial equation, like the one that we got just now. You can get an exponent, which is ln or e. And you can get a log base 10, so LG. I think that's all the equation you get, no more already. Okay. Number 2, will you get trigo? Sure. But not the type where you need to use identity. Normally, it's from resolution of forces. So you just need to know how to measure the angle. This is question 2. Okay, anyway, so how to linearize the equation into the format y is equal to mx plus c. Basically, if you do physics and you don't know how to use this equation properly, your life is just hard from paper 3 to paper 5. Okay, number 2, we are still going to deal with uncertainties. So case 1. Case 1 is the fail-safe method, meaning if you don't know what identity to use and you look at the equation and go like, what on earth is this? How? Okay, you just, never mind. You can always take half of the range. So let's say half of the maximum value, wherever that maximum value is, that can be gradient, can be y-intercept, minus minimum value. And sometimes this is the only method that you have. So this one can be used for all calculation, but this is pros. The cons here is it is going to be a lot of work for 1 mark. You say you don't want the mark, also cannot. Like. Everything also 1 mark in this question. Okay. Case 2, you can use identities. Okay. So there are 2 types of identities that you can. Okay. So I need to hang on. Let me talk about case 1 a bit more first. There's a slight exception that to case 1 that you have to use. For example, sometimes they will give you. We always use this for looking for uncertainty in gradient. So that would be modulus the gradient of your best fit line minus the gradient of your worst fit line. Go and watch the videos where we draw best fit line, worst fit line. Okay. The second one is the uncertainty of your y-intercept. We will also take modulus the difference between the best y-intercept minus the worst y-intercept. Okay. Next one, case 2. When we could deal with identities, but we can only deal with identities if, let's say, we know the equation. Okay. So if we don't know the equation, then you cannot deal with identities. So the first one, the first identity we have is uncertainty of if A is B plus C or minus C, then the uncertainty of A is the uncertainty of B plus uncertainty of C. The more measurements you take, the more uncertainty you have. Okay, the second case, if A is equal to B squared times C divided by D power 3. I don't know lah, whatever this value is. This one, we must use fractional or percentage uncertainty. So the percentage uncertainty for A is the percentage uncertainty of B, because when you calculate A, you measure B, but 2 times because you square the B, okay, plus uncertainty in C over C, percentage uncertainty, plus 3 times the percentage uncertainty of D. Okay, so this one can use, no? Third one, log and ln. Let me put a star here. There's a video where we derive this equation, but right now at the eve of exam, ain't nobody got time for derivation. So if for log and ln, if let's say, right, you really don't know the actual identity, it is perfectly fine to just operate on maximum and minimum values. Okay, it's perfectly fine. There's no problem with doing that. But if let's say you actually know the identity, then you can use it. So if log, well, let me think a bit, because currently I cannot remember the identity. So sometimes I also will have to use the max min value. Let me go and dig the notes a bit, because I don't have my paper 5 with me now. Log and ln. Okay, so half range always can. Okay, so here's the identity. If y is equal to log a to the power of x. So in case you don't know what this one is, this is your base, this is your number, right? Let me pull out calculator to explain. Where is my calculator? Okay, here is my handy dandy calculator. So when you type this into your calculator, it's log base 10. This one, your calculator is log 10. This is 10. And then whatever we put inside here is the number. So that will be this log. Your calculator only got 2 modes that is available to you at this setting. Okay, you either log, let's say you log 8 lah. So that one is log 10, 8. So A is 10 and X is 8. Okay. Another one that you have is this one. See? So you can put 10 here and then you can put 8 here. And then I go and minus this one just to show you they are the same thing. Log 8. You're going to get 0 lah. Of course, it's the same thing. Okay, these two are the same thing. So the other one that you have is ln. Ln is log base E. Okay, so log, this one is normally written as this or this. Log base E, we don't write log base E1 ma, we write ln. Whatever lah, it can be 8, 8, 8. It can be 4, 4. Okay. So whenever we have this format, right, if you want to find the uncertainty, there are two outcomes. Okay. The uncertainty of Y, which is now the uncertainty of log A times X. This uncertainty is equal to 1 over ln A uncertainty in X over X. Okay. The derivation is in the playlist. If you want to know, if you don't want to know, you can just use only, but it will not be given in the exam. Okay. So this A is your base. So let's look at the first case. If A is equal to 10, because this one A equal to 10 ma, this whole line here, A is equal to 10. So if A is equal to 10, then your uncertainty of log X, because 10 become log X, will be equal to 1 over ln 10 uncertainty in X over X. This got log question came up before. Oh God. Next case. If A is equal to exponent, then the uncertainty of ln X will be equal to 1 over ln E times uncertainty in X over X. But 1 over ln E is 1. So this one would be uncertainty in X over X. So you have this and you have this. Can? Depending on the question, no. Different question is different, ma. Right? So the whole idea here is you should follow the general rule of thumb. If you know the identity, you can use them. If not, you can use maximum minus minimum. Let's look at an example. Okay, this is log base 10, right? So what you're going to do is you're going to press log, but you want to check out the exponents. You see this part here? The exponents are not inside. Meaning when you log, right, this one should be log 129 times 10 to the power of 6 meter. Because now this one is in meter. All right. Compare this to, let me check. Compare this to the other one. Where your table is like this. This is the question from ON16 paper 52. Hang on, I have to dig out the question. compared to this table here. You see, this one, they put the prefix inside. Hiya. This one here, this one, the prefix is not inside. So you should press this one. This one, the prefix is inside. So when you press calculator, it should be log 630. Means why they do this to us? I don't know. I don't know. Just be careful lah. Just look. They are not consistent one. Every that's a different thing. So if you want to try this question, this is from ON19 paper 52. And if you want to try out this question here, this one is from, I think all of this is in the set A, set B, ON11 paper 52. Okay. So when you press your calculator, you should be able to, this one you use the prefix. So this one is 8.111. Okay. Second thing about this is, this one is 3SF. So this one, when you transfer over to here, it has to be, this is very weird. This will be same DP. So this must be 3DP or 4DP. So normally, right, when we transfer values, okay, let's say we look at a table that is not log and lon lah, just a regular old table. Let me go and find another one. Okay, maybe this one. So this one, you 1 over A. This is 2SF. So this one is 2 to 3SF. 2SF, 2 to 3SF, 2SF, 2 to 3SF. This one is a standard one that you always do, because normally I will just tell you, this one is a calculated value. So we look at the SF of the original value. Then we transfer. But for log is a special cookie. Not only prefixes can play hide and seek with you, sometimes it's inside the log itself. So like for example, this one, you will press log 630. Press my calculator, 630. And that would give you 2.799. So this is 3SF. So this one should be 3 or 4 DP. We go from SF to DP, which is very weird, only for log. So this will be 2.799. I can put 799, or I can put 2.800. No, this is 3DP, 799. Or 7993. Okay. So in a nutshell, when transferring DP and SF, for everything else, we will follow the least SF or +1. Everything else. For log or lon, we will follow the SF, but it will become DP or +1. So example, log 630 will be equal to 2.799 or 2.7993. This one is 3SF. So now it's 3DP or 4DP. Okay, this is the part that is confusing. The other parts are pretty standard. It's just that for log and ln, they have a special way for you to find the uncertainty. There's also a special way for you to calculate the value for how many DP and SF to put, basically. Okay, so one last thing. If let's say you are asked to find the uncertainty, for example, for V, okay, so you have two choices. Let's look at the first one. Let me do log 1.9. So this value here, again, this is 2SF. So I reach here, I can take 2 to 3 dp. Let's say I stick to 3 dp. This is 0.279. Okay. So 2SF, then we reach here. 2SF transfer here would be 3 dp. From here to here. Okay. This one, 3SF, transfer here, 3 to 4 dp. Okay, let's talk about the uncertainty, plus, minus. You have a few options. For this one, you can either take log, you want to do half the range, 1.9 plus 0.1, 2.0, minus log 1.9 minus 0.1, 1.8, divided by 2. Can. Option. This is half the range. Option 2, use identity. 1 over ln 10, 0.1 over 1.9. Means the answer the same. I press now. 1 over... You can press another one if you want. But anyway, divide by 1.9. This is 2. I mean, I'm just going to take 1 SF, but I guess I can take another one just for comparison purposes. It's ln. Wait, this is a bit wrong. Sorry. Right wrongly. This is ln 2.0 minus log 1.8. So max minus min. Log 2 minus log 1.8 divided by 2. I get 0.023 as well. So it's up to you lah. Some student, this is fast. The bottom one is faster because you don't have to go through the mental arithmetic of 1.9 plus 0.1 and 1.9 minus 0.1. Because sometimes this uncertainty will be some weird number like 15, 4, and 8. GG. So this one, this uncertainty will be either log 28 minus log 20 divided by 2 or 1 over ln 10 bracket 4 over 24. So you just take this one divided by this one, this one divided by this one. And it's always 1 over ln 10, 4 divided by 42, 8 divided by 154, 8 divided by 304. This is faster. This is slower. This is, I guess, you always know half the range. So totally up to you. This one can be a mixture of SF. Please practice paper 2. Things like drawing best fit line, finding absolute uncertainties, finding uncertainties for things. Okay. We already recorded the Feb March 2-1 paper. So you can try out that paper first and then come back and compare answer and compare methods. Practice at least 5 different style of tables. So if you do one log and then you do another ln one, then maybe you find one with angle one. There's one, so all the set A, set B should be enough. There is one particular one in set B that I want to point out. This is a slightly anomalous case. Okay. So for set B, you see this one? This one got log, which is okay, and T. And you see, include absolute uncertainties in T and in log T and S. So they need absolute uncertainty here. I also need absolute uncertainty here. So sometimes students is confusion. This one got absolute uncertainty, got half the range. So the uncertainty for this is half the range of these two numbers. Okay, let me explain to you what I mean. The uncertainty for this, one, you see, this is T, and based on the question, I think it's 10 oscillation. So you see it's going to oscillate up and down. This T is time T for 10 oscillation. So you're asked to find the period. Okay. So to find the period, what we are looking for is the average of these two. Average of these two is 1.56. I mean 15.6. Okay. And then after that, this one will be 1.56 because this is 10T. So 1.56, and then what we'll do is we'll plus minus. Plus minus here, you need to do the maximum minus minimum. So 16.0 minus 15.2 divided by 2, this will be 0.4. Okay, but this is for 10 cycle. This T is 1 cycle, so this will be 0.04. Okay, I'll repeat again, everything else. So if they give you plus minus, that is great. If not, then you have to include your own. But the good thing here is I think all the range is 0.8. See, 0.8, 0.8, 0.8, 3 and 11, 0.8, 3 and 5. So 0.8. So the difference is 0.8. You want to find the uncertainty, will be half of the difference between maximum and minimum value. So what I'm doing is uncertainty in T, the small t, will be equal to T max minus min divided by 2. Okay, so hence the uncertainty for period will be the uncertainty for 10 cycle divided by 10. Okay, then you go and log this one. Just make sure you always check the bracket. Hey, S and S. Okay, so no need to worry about prefix. In fact, 1.56, no need to prefix. Okay, so that's generally what I want to focus on in question 2 for this session. So this is not enough. You need to go and spam do some questions and see whether you can finish on time and get familiarized with the paper. It's not a very hard paper. It's just, do you know your experiments or not? And do you know what to do when we give you some data and ask to plot the graph and find the gradient and the y-intercept? Okay, so all the tips you can find in the discussion recording for Feb March 21 question 2. Right. So that's it for paper 5. Just stay calm. My general strategy for students is do the question you are most comfortable with first, whether it's 1 or 2. But be aware that sometimes don't spend too much time in one question unless you totally don't know how to do the other question, which is what I hope will not happen. So I will. Okay, so that's it for paper 5. Just go through your weaknesses, whether it's question 2, time management, or finding uncertainties. Cover a range of different types of questions, okay? And also, whether it's paper 1, designing the experiment, learning to curate all the information inside a table format to help you organize your brain, learning how to linearize, and also learning how to draw diagrams. Okay, so hope this is helpful to you. Stay calm, stay cool. I'll see you. Guess I won't see you anymore, will I? All the best for your A-levels and in your life. You've been doing very well so far. Trust yourself, one thing at a time. And it's not easy to study online, alone at home. Just so you know that you are doing great. Okay. Peace out. Bye-bye.